to switch over to my iPad.
I have no face.
Yes, I trust this computer.
I know, I did that. I'm not looking cute enough to have my face.
Taylor, you're cracking me up, whatever it is you're doing.
It's Palo Santo. It's supposed to get rid of the negative energy in the room.
What?
Oh, but you can't leave. You can't leave your own room.
That's why I got to put the Palo Santo up in there. I can't leave because I can't leave. That is exactly why.
Trapped.
Okay. Anyway, hi Nala. Okay. Okay. So is everybody good on the previous page?
Yeah.
That's where we ended.
I have a screenshot of it.
Yeah.
Okay. Cool. All right. So then here, moving forward. So there's two other types of problems in this section, and they're all kind of basically related. But what we just talked about is if you mixed, all of these problems we're talking about, if you mix two things together, and the question was, will it make a solid? This next set of problems is a little bit different. It's still, let's mix two things together. But then the question is, how much of an ion will still be in solution? So the idea here is that you will make some solid. So we are assuming that you are going to make some solid, but since we're starting off with two different amounts of the individual ions, because we're mixing two solutions together, that you will have some ion left over. And the process to do this is still essentially relatively the same. And they do kind of talk about it in this problem. So it says here first, so step one is determine the concentration of ions in the solution. Okay, so step one would be determine your ion concentrations, right? Then your second step is to figure out what the precipitate that forms is, right? So second step would be determine the solid. And again, just like last class, they're making this as easy as possible. So your spectator ions are going to be obvious. They're going to be sodium and potassium. They're going to be nitrate, things like that. So you're looking at the cation and the anion that are weird and assuming that those are going to be making the solid. Besides the fact, again, they have to give you the KSP. So that is telling you what solid is going to be made. So once you know that, you're going to write your equation, right? So write your expression, or write your equation. And then write your expression. And then there's going to be different bits of information. So they have to tell you the KSP. They have to, because there's no way to be able to do this. So you would, that last step is use the KSP and the concentration of ion to find the other ion. All right. So what it would end up being, and they kind of like go through it here, is, so for instance, you would have this number, you would have this number, and what you're being asked to find is this number. That's just really simple algebra. That's all we're doing here. So make sure you have that stuff written down, and then we'll turn the page to actually start working through the practice problems on the next page, because I don't like the way they do the samples.
Sidebar thing is blocking the instructions.
Oh, my bad. There's Jordan.
She's getting on. She was just asking how to get on. So we just sent her the link.
Ah. All right, does everybody have all that? I'm assuming with the exception of Jordan, who just jumped in.
Yeah, I'm here.
No, I see you.
Great.
Nala, you know where Wendy is?
No idea. I'll text her now.
I asked like you were her keeper, like you guys are like sharing a dorm room or something.
We might as well be. We had like we called each other the other day and we're just talking.
I mean, that's cute and all, but I don't really like anybody like that. Like,
I'm not a phone call person, but Wendy will call you and you can't really not answer. So
my
Yes, you
grandmother
can.
calls me and I don't answer. It's easy to not answer. You just don't answer.
Mm-hmm.
but then
You
she
let
just
that phone
texts you and
ring.
texts you. So it's like
And you don't
just
send a
answer the phone.
response.
Yeah, you don't. You have free will, Nala.
Yes, there's always a choice. Always.
It's always a choice.
Okay, I'm gonna try. Whoa, what was that?
It was me. Guess what?
Okay,
I got into USC.
you got into USC?
Yeah.
Hell yeah! That was your number one.
Yeah.
That
I'm
is
so happy.
awesome.
That's really good.
Yay!
Thank you.
Was that for their film program or their theater program? Or is it the same?
It's the same thing.
Okay.
What page are we on?
We're about to turn to page 254.
Okay.
Bam, there we are. We turned to page 254. Ba-ba-ba.
I'll send a picture of those. Actually, no, she has the video. Never mind. The video.
Yeah, I was about to say, she got the video. She'll catch up. It's fine. Okay. All right, so let's start with number one here. So it says calculate the maximum strontium concentration, right? Strontium ion concentration that can exist in solutions of the following. So how much strontium can exist in this much sodium, 0.045 molar sodium fluoride? So sodium fluoride is NaF, and which of those is going to react with the strontium?
The fluoride.
The fluoride, right?
Okay.
Yeah.
And we all said it so
You're all like,
hesitantly.
yeah. Sodium's always going to be the spectator there. So step one told us to figure out the concentration of the ions, right? So the only thing I have here is the 0.045. So I know that my concentration of fluoride is 0.045 molar. So I have that piece of information. And then my second step was to figure out what my solid is. So what would be the formula for my solid here?
SRF2.
SRF2. oops, solid, because you've got that 2 plus there and then the minus there. Okay, so that's my solid, and then I'm going to write the equation for it. And I am remembering that this 2 becomes that 2.
Oh, right. Take it.
Okay. My next step was to write the KSP expression. And again, remembering that that 2 now becomes that 2.
Mm-hmm.
Right? And then it's basically like plug in the information and solve for the strontium. So in an actual problem, they have to give you the KSP. In this practice problem, they're assuming that you're going back and looking it up in the chart. So I'm going to give you the KSPs that you know. But from the text itself, 4.3 times 10 to the negative 9th is that KSP. I'm looking for the strontium. And what am I going to put in this F minus spot?
0.045
But squared.
squared. Yeah.
Yeah, so I'm going to put that in, and I need to square it. Notice I'm not doubling it, right? I'm not doubling it because they're giving me the number. This is the number. So that's just the straight number I plug in. So then you would square that and divide the KSP by that. And in your calculators, what do you, if you do the square and do the division, it's going to be a small number for 2 sig figs. So
That was not what I wanted to do.
We just have that divided by 5 equals.
Should we say what we got?
yes,
Okay.
what's your
I got
answer?
2.1 times 10 to the negative 6.
Yes.
That's what I got.
Yay.
Yep.
Ah! Get it?
Okay. So that's all these problems are, right? So it's literally just if I put some amount of strontium, you know, if I mix these two things together, all of the strontium would form a solid with this available fluorine, and that is the maximum amount of strontium that could exist otherwise, because everything else is going to end up being in the solid. So for these others, well, I know that lithium is a spectator. So carbonate, what is the formula for carbonate?
CO3.
What's its charge?
2 minus.
2 minus. Okay.
Not know that.
So what is the solid that's going to be formed here?
SrCO3.
SrCO3. All right, so I'll go ahead and tell you that the KSP value for that is 5.6 times 10 to the negative 10th. And for this last one, what's the formula for sulfuric acid?
HS.
Yeah, H2SO4.
H2SO4.
Wow. Dang it.
Yes, yes. Okay, so in this instance, what's my spectator?
The H.
The H. Because sulfuric acid's a strong acid, so H will be a spectator. So my solid formed there is SrSO4. And that KSP value is 3.4 times 10 to the negative 7. So there's your KSPs in your solid. So map what we did in the first one and go ahead and do B and C and see what you get for that final concentration of strontium on these two problems. They will also be small, but they're not going to be the exact same numbers.
On B, the KSP says 5.6 times 10 to the negative 10th.
Yes, ma'am.
Okay.
Yeah, my craptastic handwriting.
See, basic algebra is just so nice.
I'm gonna go get more coffee. It's
Have
important.
fun.
What's the charge for SO4?
2 minus.
2 minus.
2 minus.
Thanks.
Guys, I'm such a jerk. I just like poured my cup of coffee and realized there was like 2 tablespoons left in the pot, and I just sheepishly walked it over to Catherine like, here.
Wow.
I know. Do we have questions? Do we have answers? What are we ready for?
Hey, Miss Biscuit.
That's kind of right slow. And I just,
Right. Who's
Okay, I have B.
I'm working on C.
Whoa, the screen just did a weird thing.
Yeah, that was not it.
If somebody wants to check their answer before we call them out, you can privately chat me and I'll let you know if your answer is right. Since some people get pissed when people shout out the answers.
How do you privately
Be
chat?
direct.
I see
Yeah,
chat.
so in
Oh,
the
you can
chat
change
window,
to- Oh, wow.
you can switch it from to everyone to a certain person.
You just be talking trash in the group chat to a specific person. Who said hi now? Kayla! I'm responding back. I'm just slow.
Yes, Taylor. Yep, Sean.
Yes, period.
I was just gonna wait till everyone was done.
I'm gonna just wait.
All right, so I'm just gonna start writing out the work for B while you keep working so that it ends up in the video, so that people can see what the answer is and how to do it.
What's Alicia? What's this?
Alicia?
So what I got?
So that's number 2.
Mm-hmm.
And the next one. So for both B and C, there was no squares, there was nothing like that, because both of your anions here had also had charges of 2- as opposed to the fluorine, which was a single minus, which is why we had to have the 2 here. So that's the basic format of the problem in general. So I'll leave that for a second, and then we'll scroll down and look at questions 2 and 3 here at the bottom. Partly it's the exact same kind of setup of problem, but you know, it's a hell of a lot more words. So part of the thing with AP is just looking at the question and digging through the words to be like, what the hell are you asking me for? So. Okay. Okay, so with question 2, it says sodium carbonate may be added to hard water to remove magnesium 2+ ions. What mass of sodium carbonate is required to soften 10 liters of hard water containing 3.2 times 10 to the negative third molar magnesium 2+? Okay, so first off, I was given a single concentration, and that single concentration was for my magnesium ion. So that's my concentration of magnesium. I've identified that. It's asking me for a mass of sodium carbonate. Now, the previous set of problems was asking me for a molarity of ion. So if I had a molarity of ion, can you imagine how you can go from a molarity to a gram amount?
Yes.
Molar mass.
Yeah, so it's just going to use the molar mass. Okay, so that means we just do the problem like we did up above, and then have to add this portion in the last part to get the thing they're actually asking me for. So if I'm adding sodium carbonate, which of those things do I get to ignore?
Sodium.
I get to ignore the sodium because I always get to ignore the sodium because it's always a spectator. So that means my solid that's going to be formed is what?
Magnesium carbonate.
Magnesium carbonate. And what's that formula?
Mg.
Mg CO3.
CO3.
Or CO3 too, rather.
We're on CO3.
Yeah. So my equation there, Mg2+, CO3, 2-. This is a lovely KSP expression because, again, I don't have any subscripts in my solid, so I don't have any coefficients in my equation, so I don't have any exponents in my expression. Always makes the algebra easier. And again, they would give to you that value for the KSP. It's 6.8 times 10 to the negative 6th.
What packet is the charted again? I forgot which one.
It's in the 4.3. It's in the previous packet.
Okay, great.
Yeah. So what they gave me was the magnesium. So I have this value, 3.2 times 10 to the negative 3. So at this point, go ahead, figure it out, and tell me what the concentration of carbonate is. That's the first step here. I love the sound of all the calculators tap, tap, tapping.
My laptop.
Dang it, there's a gnat in my room.
All right, so for two sig figs, what are we getting?
2.1 times 10 to the negative third.
I'm just like always too slow to say the answer. Like I said, my thing. Anyway, yeah, you're right. Shaw.
Okay, Miss Baskin, I'm clearly doing something wrong with my calculator. For
Did you get
this,
0?
all you had to do
0.002125?
is that what you got?
That's what we all got. We just rounded it. We just put it in scientific notation. So we
No, I didn't get that.
Oh, well.
So
And I know all you have to do is divide the 3.2 times 10 to the negative third divided by 6.8 times 10 to the negative 6, right?
nope, opposite way.
Oh. Okay.
Yeah, because I'm trying to get this guy, so therefore I'm dividing by the 3.2.
Okay.
Yep. Okay, so now I've got my concentration of carbonate, and I need to get that to grams of sodium carbonate. So where do I actually start?
We have the liters. So
We
can
have
get
the liters, so
moles.
we're going to start with the liters. Okay, so we're actually going to start with 10.0 liters. And what goes in the next step?
Liters is in the denominator.
Moles over liters?
All right, so 1 liter in the bottom,
Yeah.
and then in the
2.1
numerator?
times 10 to the negative third.
Yep, the 2.1 times 10 to the negative third. And that's moles of carbonate. Now, it's not really needed in this problem, but just in case it's in a future problem, do note that that is the carbonate, and this is asking me for the entire compound. So it's not going to change anything in this problem, but in 1 mole of carbonate is 1 mole of sodium carbonate, right? It's a 1-to-1 ratio there because there's only 1 carbonate in the formula. But if I was dealing with sodium, you know, that would change things, but. Okay, so has somebody figured out the molar mass for sodium carbonate yet?
Didn't even think about that.
That's what I'm saying. I forgot.
Miss Baskin?
Mm-hmm.
Where did we get NaCO3?
Because that's what sodium carbonate is.
But I thought we were doing MgCO3. We
Well,
did that in the beginning.
Yeah, we did that to get the carbonate, but the question wants to know the mass of sodium carbonate.
Okay.
Is it 83?
It is not 83.
Oh, what is?
Isn't it 105?
105.99.
Hurt.
Wait a second.
Oh,
Wait a
because
second.
there are 3 C's and 3 O's.
No, 1 C, 3 O's,
Right. So
but 2 sodiums.
Wait.
I only have 1. Girl, you okay?
No, I see it, but I'm not reading it in the calculator. What's the number?
Okay. So, because it's 22.99 times 2 plus 12.01 plus 48, 105.99. Okay, so when you do all of that, What is the mass? What is my actual answer?
2.2.
Yes.
Yay.
I'm gonna still do it. Hold on.
I believe you. I trust your judgment.
Yeah, I agree.
But why would they? So we needed to do all that to find the concentration of CO3 to then go back to see the sodium carbonate. Okay.
Yes. Because you don't want to dump extra sodium carbonate in there. Like, you don't want tons of carbonate ions floating around, but you want just enough carbonate to be able to pull out the magnesium. So if you actually, and Sean, actually where you live, you might actually have water softeners. It's basically like on your incoming water line down where you'd have something, it would be like this big canister looking thing that would be filled with pellets, essentially, that the water runs through, and it's designed to do this exact thing. All right, it's designed to extract these extra ions that are in the water that make it taste funky and make it like not lather with your soap and stuff like that. So that's literally actually what these are.
Oh wow! Yep. Wow.
Yep.
Well, you know.
And people out in the country who have well water tend to have those.
Well water.
So we're not going to do number 3 because it doesn't actually have any numbers. So it's not like I'm not going to waste time at this point on problems that are not going to be like what we're going to see on the AP test. So like, forget that. And that's it. I just wanted to go over this kind of problem today. And we will have class on Monday to go over the common ion effect. So we're not doing super long classes, but we are still going to meet 3 times a week for these like little 45-minute sessions. And 4.4, those questions are not due until Wednesday because we'll finish everything up on Monday.
Wait, 4.4 is the last unit.
Yeah.
In this section.
Yeah.
Wow.
Yeah. So, and I will say, because I talked to Miss Snyder, we had a department chair meeting yesterday, and I need to get a little bit of clarity, but apparently it's up to you guys as to whether or not you want to take your AP exams now. And I need to ask for clarification because it used to be if you didn't take the exam, they wouldn't give you the GPA boost.
Oh, come on.
So wait, run it back. Say that one more time.
So I need to ask if that policy is still in place.
Take me off that list. Take me off the list.
Taylor.
Take me off the. I'm gonna leave this chat. Amen. Take me off. Calm down.
Wait a second. I need to hear what is going on. I mean, I get my GPA boost.
Say it again, please.
Right, I'm getting my GPA.
Wait, so is it like for all the AP classes or just this one, Miss Baskin?
All right, let me mute all of y'all for just a second. So what they said yesterday is that because the test changed and it's now free response only in all classes are now free response only, and they're going to be computer based, and we don't really know what they're going to look like. What they're saying is that students have the option of whether or not they want to take the test. My question, which I will ask today, is are students going to have their GPA boost for the AP class removed if they don't take the test? Because that used to be the stick that they dangled in front of everybody and said, if you don't take the test, you don't get the extra GPA boost at the end of the year. And I think that that is a big factor for people, and you may want to ask or know the answer to that question before you make a decision about whether or not you take the test. Would that be fair?
But be prepared. Let me pause this music. Sorry.
Yes.
Be prepared to take me off the list.
Now,
Let me go tell Miss Shaw, because I'm not taking that AP calculus test.
Yeah, you guys would take yourselves off the list, not me.
Really?
Listen.
So what, do I like unregister like in AP? Oh, okay, I'm gonna wait.
I don't know, because we're waiting for more information on April 3rd. So between now and April 3rd, hopefully I can get an answer from Ms. Snyder and DCPS about what they're going to do with the with that GPA credit.
Okay.
Taylor, you ugly.
So hopefully by
gonna be real-
Monday's class, I'll have more information.
But it'll be bad if
I'm-
there's no GPA boost.
Yeah.
You're gonna be sad.
You said what?
Oh, look at Carl's dog.
I know.
Because
So well
if there's
behaved.
no GPA boost, then I will be forced to take this exam.
Yeah.
Because that's the only reason I took this class. I don't care about the credit. It wasn't going to apply to me. I wasn't going to use it.
I love you anyway, Sean.
I love you too, but I came here for the GPA boost. That's it.
No, literally, Sean. Like at this point, just hurry up.
At this point, either the exam, if they say I don't need it, I'm gonna be like, well,
Well,
That's gonna be real empty.
that is made my entire
By
week.
yourself, Jackson. You better be in there by yourself taking that test. You got it.
Oh, Jackson gonna sit there. Jackson and Grace.
SAT score, yes, he is.
Maybe Simone if she's feeling like it. You know, it's gonna be real cute.
All right, Jackson and Grace can give me my 4s and 5s. That's cool.
Yeah.
Yes. It depends. I may sneak in there and give you a little
that?
3 or something.
What's that?
A little 3, something cute.
Okay, so for everybody who's submitted work, I am starting the process of grading those questions, including the makeup work that people have been giving me. Keep that makeup work coming, and I'll keep grading it. And that's it.